Okay, so the last time we talked about the sign of inequality. So let's apply that in simple equations. Now, before now, if we have an equation of 2x plus 5 equal to 15, before now I taught you that you're going to separate this, right? By doing plus minus 5 to both sides. So you're going to minus 5 here. So in other words, you're going to have 2x plus 5. Sorry, this and this, 5 minus 5 give us 0. So you're having 2x. Then this is going to be 15 minus this will give you 10, right? Then you divide both sides by the coefficient of 2, and you get a value of this to be 5. So you must have seen this in my previous video. Fine. And now, this is fine. But if we have a very complex number, a very complex kind of equation, we will end up adding, and subtracting, adding, subtracting, so it becomes very cumbersome. So this can also be solved by using the sign of inequality. Very simple, obeying the sign of inequality. And if you're forgotten, when a number crosses the sign of equal to, so if the number is 5 and it crosses the sign of equal to, it becomes minus 5. If it is 3 and it's crossing the sign of equal to, it becomes minus 3. And if it is minus 2 and is crossing the sign of equal to, it becomes plus 2. So this was what we learned before now. So in other words, if we have to apply that rules, in the case where we have 2x plus 5 equal to 15, and we have to apply collecting of like terms, so we can see that these two numbers are of the same term. Is that okay? They are similar data. So you can collect these numbers together. So what will you do to collect that? You're going to say 2x. So this number, we have to travel down to this place. Now, don't forget, it's going to cross the sign of equal to. Here, it's a positive number. So when it crosses the sign of equal to, so this is 15, still written. When it crosses the sign of equal to, it's no longer plus 5, but rather minus 5. And when you do that, you're going to get 10. And you divide both sides by 2, you get a value of x equal to 5, just like that. So just the way you did this. Now, this is more efficient in a case where you have lots of, data on similar data to bring together, and it is, trust me, this is much more efficient. So let's move on. So let's pick up a situation where we have 3x minus 2 equal to 4x, right, minus 3. And we want to solve for this. So this is a simple equation. So we follow the rules. So these two numbers we have to be together, right? And this other number we have to be together. That's how you collect your similar data. So you make sure that the variable you're looking for, that is, the variable and the constant are not on the same side. So these are the variables 3x and 4x. The constants are the one that doesn't have the number attached to it. So you can bring it this way. So I can decide to say 3x should remain here. I want the x to be on the left-hand side, and I want the constant to be on the other side. So this 4x will come in here. 4x was plus 4. Now, crossing the sign of equal to, coming down to this place, is going to be minus 4x, right? And this still remains here, is not crossing the sign of equal to, that's minus 3, is still here, not crossing the sign of equal to. But the minus 2 is coming down this way. So minus 2, if it comes down, it becomes a plus 2 because it's crossing the sign of equal to. So let's subtract this now. So when we subtract this, we're going to get minus x. So we know that the signs are different. We subtract and put the sign of the larger number at the answer. So you can check out the sign rule if you're still having issues with this. So this is going to be equal to the minus 3 plus 1. The signs are different. We subtract, that gives us minus 1. Very simple. So we can't be possibly having a value of minus x equal to. So we want to have it like x equal to. So we're going to divide by the coefficient of x. So the coefficient of x in this case is minus 1. That's what it is. So we divide both sides by minus 1. So by so doing, the minus take care of the minus. And in case you don't know, minus divide minus is going to be plus, right? And plus, divide plus is going to be plus. The minus divide plus is going to be minus. Just the same way you have the first one. So in this case, we're going to be having x equal to 1. Very simple. So I'll just keep this aside. So let's take this last example. So I'm going to call this B, and I'll call this first one A. So similarly, if I have 1 over 2x equal to 1 over 4 plus 1 over 4x. Also very simple. What do? I tend to bring this together because they are having the same variable. So this is going to be 1 over 2x minus 1 over 4x, then equal to 1 over 4. So when you do that, half minus 1 minus quarter, if we're very smart in our maths, it's going to give us half. So this is half x. So you can take it and just look for the LCM. So let's do that. Looking for the LCM. Mind you, this means 1 times x, which means x over 2. So this is as good as x over 2, the minus x over 4 equal to 1 over 4, right? So you can do this and say the LCM between this number is 4. So 4 divide 4 here give us 1. 1 times x give us x. And 4 divide this give us 2. 2 times this give us 2x. So we have this equal to 1 over 4. So when we subtract, we're going to have x over 4 equal to 1 over 4. Now if you cross multiply, you're going to get this. So I'll just try and squeeze this here. I don't want to go to the next slide. So we have 4x, right, equal to 4. So we can divide both sides by 4, and we get a value of x to be equal to 1, just like that. So this is we applying the rules of equations, that when a number crosses the sign of equal to, it changes its signs, and applying the rules of collecting of like terms. So we'll be doing more of this in our next video. Thank you.